Today we're talking about transformations, and you may have heard this word transformation before, maybe transformers. So you know that transformations mean to change. So we're going to talk about some changes that you can do with shapes. So you start with the pre-image. The pre-image is the original figure before the transformation. So in math or in geometry, we use, let's say it's a triangle, we're changing a triangle, we're starting with triangle A, B, C. And then after we go through the transformation, we call it triangle A prime, B prime, C prime. This is the image or the new figure after the transformation. So these little apostrophes are called primes. And that shows you where you end up. So different types of transformations. Well, we talked about transformation means to change, but specifically it's an operation that maps a pre-image onto an image. Like we said, we start with a pre-image, which makes sense. This pre means before, like a pre-test. It's before. Let's talk about the different kinds of transformations, different ways we can change shapes. We talked about one of them already, and that's a translation, which is a slide. That's one way we can change shapes. Another way we can change shapes is a reflection. We can flip it over a line. You can also rotate a shape. And you can change the size of a shape. We call that dilation, to make a shape bigger or smaller. These are the 4 transformations that we are going to be talking about in this chapter and in the next chapter. So an isometry is a specific type of transformation. It's a transformation that preserves length. So what do I mean by preserves length? I mean it keeps the length the same. It keeps the shapes congruent. Another way to think about that is a rigid transformation. That's another name for an isometry. You know, when people or something is rigid, it doesn't change. It keeps it the same size. So if you look over here at our list, translation, reflection, rotation, dilation, these top 3 are isometries. They keep everything the same. But a dilation changes the size. So dilation is not an isometry. So let's write over here isometries. So these 3 keep the shape the same. This one does not. Let's take a look at an example. Naming transformations. Use the graph at the right. Name and describe the transformation. So we've got these are our choices. Well, it looks like, remember, we start with the regular letters and we go to the prime. So it looks like it slid right and up. So that is a translation. A went on to A prime, B went on to B prime, and C went on to C prime by going over 1, 2, 3, 4, 5, 6. So we went up and to the right. Let's put some numbers in there. We'll say right, 6. And then we went up 1, 2. So put a 2 right there. We went up 2 and to the right 6. So that's how you describe a transformation. Here's the name, and then you have to describe by saying what it did and how it did it. Letter B says, name the coordinates of the vertices of the image. The image is the new figure. So it just wants us to say, where is the new figure? A prime is at 1, 3. B prime looks like it's at 4, 7. And C prime is at 4, 3. Now it says, is triangle ABC congruent to its image? Are these two congruent? Well, it looks like it. If we wanted to prove it, we could count 1, 2, 3, 1, 2, 3. Okay, this side is the same as this side. 1, 2, 3, 4. 1, 2, 3, 4. This side is the same as this side. And then we could use the distance formula and see if these sides are the same. And then we could use SSS. Or we know these are right angles because they're horizontal and vertical lines. Now I can use side angle side. So SSS or side angle side to show that these are congruent. So this is an isometry because it preserved the lengths, because these were congruent. It stayed the same. All right, and I want you to do the checkpoints. You have to name. So use the list of those four: translation, reflection, rotation, dilation. Then you need to describe. So if it's a translation, tell me where it moved. How much over, how much up or down. If it's a reflection, tell me over what line. And if it's a rotation, tell me how many degrees. And then, is it an isometry? Did it preserve lengths? So pause the video now and try that on your own. All right, now that you've had time to look at this, this is a reflection. If you look here, A went onto A prime, B goes onto B prime, C goes onto C prime. It's a reflection. To describe that, we're going to say over what line? Over this line, that's the x-axis. So the word they use is in the x-axis. But you can say over, that's fine. It's a reflection in the x-axis. And is it an isometry? Did the shape stay congruent? Yes, it did. Over here, a lot of people are tempted to say reflection. But think about if A were reflected, A would go here. And B should go there. So this is not a reflection. This is a rotation. See, A rotated to A prime, B rotated to B prime, and C rotated to C prime. How many degrees? Well, if you look, we connect going through the origin. Those are straight lines. It rotated 180 degrees. Doesn't matter which way, clockwise or counterclockwise. And yes, it is an isometry. The triangles are congruent. All right, does it appear to be an isometry? Does it preserve length? Are they congruent is another way of thinking about this. So these shapes are not congruent. It is not an isometry. These shapes are congruent. So it's an isometry, and these shapes appear to be congruent. We're just looking for appear. So yes, they are congruent. It preserved the length. In the diagram, triangle JKL is mapped onto triangle MNP. The mapping is a reflection. Given that triangle JKL went onto triangle MNP is an isometry, find NP and angle M. All right, this right here tells you everything you need to know. It's like your congruent statement. It tells you what went onto what. So if J is in the front and M is in the front, J goes onto M. K goes onto N, and L goes onto P. So if we want to find NP, here's NP right here. NP is the same as KL. Let's go mark that. NP is the same as KL, which is 9. So we know that PN, or NP, is 9. Now let's look at angle M. Well, here's angle M. Angle M is the same as angle J. angle M and angle J, which is 48 degrees. All right, now you're going to try. Does the transformation appear to be an isometry? Make sure you explain. And here we go. You've got this statement right here. Use that. You need to find xz and angle y. So pause the video and try these now. Hopefully for this you see that these two shapes are congruent. They stayed the same. So yes, this is an isometry. You could say the lengths were preserved. That's one way you could explain. You could say the size was the same. You could say they are congruent. All of those are perfectly fine ways to explain an isometry. The shapes are congruent. Anything along those lines is great. Now here, let's see, I want to find xz, so that goes with AC. xz and AC are both 17. Angle y goes with angle B. Oh no, I don't know what angle B is. Well, you could assume, or you could actually figure it out, because I know there's 180 degrees in a triangle. So, let's see, 180 minus 36 minus 54, 90 degrees. So angle B is 90, which means angle Y is 90.